Today it's Thursday, March the 4th, 2021, and in this video we basically provide an overall view of the cabinet. This particular cabinet has been tested. There's just very minor work, like little adjustments, but this is pretty much ready to go. I want to point out the different components that make up this cabinet. We have here the cabinet fan, and it has its exhaust. It also has a cabinet fan thermostat that will be set by the customer. We have the 200 amp circuit breaker with its flange disconnect feeding 3 fuses. Then from the fuse terminal plug, it goes into a DC AC contactor, 3 AC coming in, 3 AC coming out, and we have 120 volts AC to energize that contactor. And here we have our DC bridge with its freewheeling diode. We have the positive and the negative output of the 3 dual SCRs. And here we have the bridge 120 volt fan. Notice that there is no electronics attached to this assembly. On the left hand side we have the current transducer, and this cable is just getting the control power. Then what we don't have is a connection between the negative bus bar going into this current transducer to pick up the 420 milliamps. Moving on here to the top, we have our snubber board at the bottom, connected across the SCRs and across the output of the SCRs. And here we have our digital 6100 board that has all the different connections to the DIN rail, and it also has the output going to the SCR bridge. We have a transformer that it's powering the 120, and we also have a transformer that it's picking up the 208 from the breaker, from the fuses, from the contactor. We're picking up here, and it is protected on its input and it's protected on its output. This provides the 24 volts AC to power the voltage transducer and the current transducer. Now, going through this terminal block, the first 4 positions are allocated to the 120 volts AC for control power, and out of this 120 we power 3 devices. We power the firing board, we power the cabinet fan that can be controlled through a thermostat, and the bridge fan that it's connected or that it's controlled by a thermostat. Once that thermostat is normally open at room temperature, once it reaches a temperature of 60 C, it will close and the fan will enable. Then we have the next 2 positions. We have SIG high, 5 and 6. That's where we bring in the 420 milliamps to control or to define the delay angle of the firing board. The next 2 positions, 7 and 8, it's where we bring in the 120 volts for 2 reasons. We essentially enable or energize the contactor, and at the same time that contactor energizes that 120 that energizes the contactor, also energizes this relay that soft enables the firing board. And here we have that soft start relay K1. Then moving along, we have between 9 and 10 what we define as an emergency stop. This is normally has to be jumpered, but when we show a test, we'll have a switch. But the vision here is for the customer to provide a normally closed contact that will open when there's an emergency. So it can be an emergency button or an emergency signal going into 9 and 10. Here we have a second relay, that's K2, and we have positions 11 and 12 being the enable status. The enable status, every time that this board is enabled, there will be a dry contact closure of a relay that will determine its status. Position 13 is just a convenient common. Positions 14 and 15 monitor, or to follow that, bimetal temperature disc that it's here in the middle of the two hottest SCRs, and it's picking up that hottest spot on the heatsink. That is normally closed, and that dry contact closure will open when the temperature exceeds 93 C. At that point, per the original design, the customer will determine if it's going to maybe command the emergency button to turn it off. We have the voltage transducer, which is picking up voltage from this transformer, and then it's monitoring the voltage across the bridge, and here we're picking up a 40-20 proportional signals. We have the 2-pole breaker coming from the 208 into the 240 transformer, and this is the output, the 24 volts AC output out of that transformer. And this basically, here we see this the position 16 and 17 jumper, and then 18, 19, and 20 jumper. That's the 24 volts AC that gets distributed to the voltage transducer and also to the current transducer. So this is basically the cabinet with no connections to it. This is the end of this video.